Hello students, I am Kokila, Assistant Professor, Department of Chemistry, RNSIT. Today we will be learning about estimation of copper in the given electroplating effluent using optical sensor or colorimeter. We are using a colorimeter for our experiment today. Let us learn about the principle of the experiment and then we will move on to the procedure of the experiment. So this experiment, electroplating effluent, meant to say the waste water coming out from electroplating operations. We will be estimating the amount of copper in the given electroplating effluent. So colored transparent solutions absorb a certain amount of light and that will be related to the concentration of the substance dependent on at a particular wavelength. When a monochromatic light of intensity I naught is incident on a particular solution, that is reflected out as say I naught intensity of incident light is equal to intensity of absorbed light plus intensity of reflected light and plus intensity of transmitted light. So here IR is negligible for glass-air interface. So the equation can be rewritten as I naught is equal to IA plus IT. This equation can be modified depending on the absorbance as IT is equal to I naught E to the power of epsilon Cp, where epsilon is molar absorption coefficient, C is concentration and D is path length. Or the same equation can be rewritten as A is equal to log of I naught by IT, which is equal to epsilon C, which is according to Lambert's law, absorbance is equal to epsilon Cp. Biot-Lambert's law states that there is a linear relationship between the concentration and absorbance of the solution at a particular wavelength. We will look out for the reaction related to the process. Copper sulfate in the electroplating effluent reacts with a certain amount of ammonia and water to give a deep blue complex of cuprammonium sulfate monohydrate. This deep blue cuprammonium sulfate monohydrate solution has a maximum wavelength. This complex has a maximum wavelength at 620 nanometer. So we are measuring the absorbance of this particular complex at 620 nanometer. So now let us go on with a brief procedure of the experiment. Here in this experiment we are taking a series of volumetric flasks, blank, 2 ml, 4 ml, 6 ml, 8 ml and 10 ml of electroplating effluents in different volumetric flasks are taken. Along with that, an unknown test solution is taken up. To all the solution we are adding a uniform concentration of ammonia. All the solutions are diluted to a particular ml with water. Say for an example, for 25 ml. We are taking 25 ml volumetric flask and all the solutions are made up to 25 ml with water. Blank doesn't contain any copper sulfate solution. Second flask, the flask number 2 contains 2 ml, the flask number 4 contains 4 ml of copper sulfate and so on. Test solution contains an unknown amount of copper sulfate whose concentration is to be determined. Our deep blue solution cuprammonium sulfate monohydrate, this complex has a maximum wavelength at 620 nanometer and we are performing our experiment. Our optical density, we read a colorimeter reading at 620 nanometer. And now we are starting the demo. We want 3 different solutions for our experiment. We want copper sulfate. We are taking 3 different solutions in 3 different fluids. Copper sulfate, ammonia or ammonium hydroxide and distilled water. We are using a digital colorimeter for our experiment. To prepare our standard solutions, we are taking 7 25 ml volumetric flasks. These flasks are numbered as blank, 2, 4, 6, 8, 10 and unknown. Now we are starting with our experiment. We are adding standard solutions to all the volumetric flasks. For the blank solution, we are not adding any copper sulfate solution. We are adding 2.5 ml ammonium hydroxide and we are diluting it to 25 ml with distilled water. Once you're done with adding distilled water, close the knob and shake to around 10 times, 10 to 15 times, so that uniform concentration is achieved throughout. We are going with flask number 2. We are adding 2 ml of copper sulfate to flask number 2. .5 ml ammonium hydroxide, and dilute the solution with distilled water up to the mark. You can see the appearance of deep blue color solution. That is because of a complex formed that is because of cuprammonium sulfate monohydrate complex formed. Close the knob, shake it for 10 to 15 times so that uniform concentration is achieved. Flask number 4, we are adding 4 ml of copper sulfate, 2.5 ml of ammonium hydroxide, dilute the above solution with the distilled water and make it up to the mark. Close the knob, shake for uniform concentration. Likewise, flask number 6, 8 and 10. We are adding 6 ml of copper sulfate, 8 ml of copper sulfate, 10 ml of copper sulfate respectively. And in the unknown solution, a given amount of test solution is taken up, and then the same procedure is followed for the unknown solution also. You are adding 2.5 ml ammonium hydroxide, dilute it with the distilled water and make it up to the mark, and the rest procedure follows. This is unknown solution. So unknown amount of copper sulfate or electroplating effluent is given, and 2.5 ml of ammonium hydroxide is added to the solution. Dilute this solution with the distilled water and make it up to the mark. we have a digital colorimeter to take our readings. We have a percentage transmission and absorbance. The wavelength is set to 620 nanometer, and the cuvette in which we are taking rinse the cuvette with blank solution. Fill the cuvette with the blank solution. Wipe the external surface of the cuvette with a filter paper. See to that no fingerprints or water trails are there on the external surface of the cuvette. Place the cuvette in the sample holder. We are changing it into absorption mode. Set the instrument to 0 using the blank solution. Once the instrument is set to 0, we are ready to run the other solutions. Flask number 2, rinse the cuvette with the flask 2 solution. Fill it with the same solution. Note down the absorbance of flask 2 solution. Flask number 2, absorbance 0.13. Likewise, take the absorbance for all the flask solutions, and then finally take the absorbance for the unknown solution. Now we are taking the absorbance of the unknown solution. Rinse the cuvette with the unknown solution. As you can see, the absorbance of unknown solution is 0.23, which is totally different from the absorbance of all the other solutions. And now we will plot a graph with all these values, absorbance versus volume of electroplating effluent. As you can see, we are done with the experiment and we have got absorbance for different solutions. To prepare the electroplating solution, we have taken up 4 grams of copper sulfate pentahydrate in 1 liter of water. So 1 ml of copper sulfate solution contains 4 divided by 1000, which is equal to 0.004 grams. Copper sulfate solution, copper sulfate pentahydrate, the molecular weight of copper sulfate pentahydrate is 249.69 grams. This amount of copper sulfate pentahydrate has 63.54 grams of copper. So 0.0004 grams of copper sulfate pentahydrate contains 0.004 into 63.54 divided by 249.69, which is equal to 0.001018 grams. So converting this into milligrams, we have 1.018 milligrams of copper. From all these values, we are calculating the weight of copper. We are multiplying volume into 1.018 as we have discussed already. 2 into 1.018, weight of copper present in flask number 2 is 2.036, weight of copper present in flask number 4, 4.072, flask number 6, 6.108, flask number 8, 8.144, flask number 10, 10.18. Now, we are plotting a graph taking volume of electroplating effluent on x-axis, absorbance on y-axis. So, the scale x-axis 1 centimeter is equal to 1 ml, y-axis 1 centimeter is equal to 0.10 units. Let us plot our graph now. We will be plotting our values. So, the flask number 2, 0.13. Flask number 4, 0.24. Flask number 6, 0.36. Flask number 8, 0.46. Flask number 10, 0.54. Join all the points passing through the origin. Absorbance of our test solution is 0.23. From there, we are taking up a perpendicular line which cuts the linear line. And from there, we are joining the line to x-axis. And that gives the point wherein it joins the x-axis gives the volume of electroplating effluent present in the given test solution. Is 3.8 ml. Now in the calculation we take up unknown volume of the test solution from the graph. We've got 3.8 ml. 3.8 ml into 1.018, which is 3.8684. This is the volume of the electroplating effluent 3.8 ml and weight of copper present in the test solution of the electroplating effluent is 3.8684 milligrams. Thank you for listening.